So good evening to all. Today we are going to see DT based video on architecture of embedded systems. So what are the things having in embedded system? How the embedded system architecture it will works. So regarding about this, it's a design thinking video we are going to present right now. So the first one who is going to present? Yashoda Devi will be going to present. Yes.
So I am Ashwa Devi from the Department of CSE IoT in SNS College of Engineering. So the DT-based architecture was, so in embedded systems so many layers are there. So first one is a perception layer. So it is a peripheral system of embedded IoT, and second one is a network layer. So it will connect the devices like Zigbee, Wi-Fi, Bluetooth like that. So next one is the middleware. So the middleware is a sensor and actuator. So it will connect the sensor and actuator in the architecture of embedded systems. So in final we have the design and development. So we combine all the layers. Finally we have the design and development. So this is a base of architecture of embedded IoT.
Good. So next one is what is an embedded system? It can be classified into three categories. One is dedicated purpose, and the second one is ubiquitous presence, and third one is optimized design. Who's going to present this? Yes, please, Samisha, carry on.
So in this slide we can see what is an embedded system. So as Sir said, it has three parts. So one is dedicated purpose. The dedicated purpose is designed for specific tasks, often with crucial real-time constraints. So embedded systems basically means that you are embedding something into a device. So when we see as the name suggests, we can understand that it has a dedicated purpose, which means that system works only for that specific task. And then when we see the ubiquitous presence, so founding a vast array of everyday products, smartphones, automotive systems, medical devices and industrial machinery. So what this says is that embedded systems are basically everywhere we use. So starting from things we use every day like our phones.
Smartphones, then automotive systems, for example, your washing machine, fridge, then electric vehicles. So in these are the examples, then medical devices and industrial machineries. So here, how it is automated means with the help of IoT is embedded. So this is the ubiquitous presence. The next one is optimized design. Yes.
So the optimized design says it is typically small, resource constrained and meticulously optimized for reliability, efficiency and performance. So as this says, the embedded systems and the devices are very small, so which means it can be used in almost everywhere possible. Like even our small smartphones have embedded systems, and even large machinery components also have embedded systems. So depending on the usage of it, the size differs, and it can be very small and used for the particular special purposes. Thank you.
Next one. Challenges in embedded system architecture. Please. Yes.
So first thing, this is constraints. Limited processing power, and then scarcity memory and restricted storage capacity, and demand highly optimized code and efficient algorithm. So this is nothing but of storage capacity and demand optimized code. Then in real-time performance, ensuring timely and predictable responses to external events is critical. After requiring specialized operating system and careful cross management. The next one is power and
thermal management. How the power is going to be minimized? How if the power is going to be minimized in your device, heat is going to be dissipated. So for essential battery power devices and confined environments, for this power and thermal management, we people are using mobile phones. So from this mobile phone, continuously we are using in your day by day in our life. So if we have any heating issues, we are not going to use the device. Is it correct? So for that, how we are going to overcome with the help of this power and thermal management, minimizing the power consumptions. Okay. The next one is
integration and maintainability. It's nothing but ensuring hardware and software interfacing updates adds some significant times.
exactly correct. How it is going to be integrated, how it is integrated, and how it is going to be maintained. So according to this criteria, the diverse hardware and software components are going to be integrated to perform a long-term device support. Clear? So next slide. Real world examples and automotive embedded systems. I hope it is handed over to Karish. Yes.
So basically everyone can understand what it is in text, but differentiate it's an embedded system, it's an embedded into one system which is already existing. So why do we actually need this system? Anyone can design anything. Anyone can build a home, but why do we rely on some person who is professional in it? You can build a design any way you want, but it should be most efficient one in power saving, very powerful, I mean fast way, and its compactability. It
And
relies-
design structures, reliability. So according to this criteria, the design it is going to be developed with the help of embedded system. Example, what the course is going to explore means it's like a mobile phone. So different types of modern mobile phones it is nowadays coming, it is launched. So each and every device have one unique quality. Is it correct? These are all the real-time examples how the embedded system will be work in that hardware and software device. Then how the device management is going to be enabled and do the process. Clear? So it was a very good presentation, and finally I conclude this is the design thinking based video about architecture of embedded systems. I especially thank to our students from second year IoT department of SNS College of Technology. Thank you to all